Today's lesson is section 4.4. We are going to talk about slope and the rate of change. So, what is slope? Well, here's what I want you to write. Slope is a measurement of steepness. Slope is the measurement of steepness. We all have heard of the word slopes when we're talking about skiing. So those of you that ski, you know that there's certain slopes that are more challenging than others. The challenge of these slopes probably deals with the steepness that the mountain ski slopes have. So when we talk about measuring steepness, we're in effect measuring, how challenging some of these ski slopes can be. We're talking about that actual measurement that you can get from, when you're skiing. So to think of ski slopes, the more challenging your ski slope is, the more steep, your mountain is. So when we talk about slope, it's an actual number because it's a measurement. It's usually given in a ratio. So let's write for our next sentence, usually is given as a ratio. And we talked about ratios in chapter 3. You know that it's basically a fraction. So if you remember in chapter 3, when you were simplifying, you guys were asking, can I simplify, can I make it into a decimal? No. And the reason why is, when we talk about slope, we keep that simplified ratio, that simplified fraction, so we can actually use that slope to find the graph of our lines. Now, there's two ways that we're going to find slope in this section. The first way is we're literally going to count our units on the graph. So in your box, let me explain to you what I mean. So you're in the box now. Your slope measures the change from one direction to the other. So the slope is going to be the vertical change over the horizontal change, because remember, it's a ratio. Horizontal change will always be your denominator. Another way that you're going to hear slope, no matter what class, algebra, geometry, algebra 2, calculus, is we refer to slope as a rise over run. So it's the change in from one point going up or down to the difference of one point going to the left and the right on your graph. When we get into the actual numbers, I'll give you a couple of steps, a couple of shortcuts. But this rise over run, you're just literally counting from one point to the next. So let's look at example 1. On your paper, you have two graphs, and I have these same graphs on the Elmo, and I want to find the slope of each line. So remember, the slope is a number. To find the slope on each line, I'm going to start at one point, and I'm going to make my way to the second point. So if I start here, you always rise first. So I'm going to put here, always rise first. So to get from this bottom point up to where the second point is, I have to count 1, 2, 3, 4, 5, 6. So my rise is a positive 6. If this is where I get as far up 6 units to get to where the second point is, to get actually to that second point, I have to go horizontally. That's my line. And we still use the same concept with your positive and negative signs. Since I'm moving to the left, my run, that number is going to be a negative number of units. So to get to that point, I have to move 1, 2, 3 to the left, and that left is denoted as a negative 3. So this is my ratio that represents my slope, but we can simplify this down. A positive 6 divided by negative 3 is negative 2. So this graph has a slope of negative 2. And what do? We just started at a point, we counted up to where the second point is, and counted over to actually get to that point. There we go. For letter B, we're going to do the same thing again. I'm going to start with the point down here, the lowest one. You can start with the other one too, it doesn't matter. You're just going from point A to point B. From this point, I have to move up 1, 2, 3. So that's a positive 3. To move over to the second point, I move to the right 1 point. That's positive 1. So the slope of this line is positive 3. So when we're counting units to find the slope, you're simply just using your rise over run. Now you've got on your paper omit. We're not going to do example 2. So I'm going to know who's paying attention and watching the notes. We're not going to do example 2. Turn the page and let's talk about the other way that we can find slope. Now, using graphs is great because it's just simple basic counting. You just have to remember that when I go to the left, I have to, change my sign negative. If I go down, I have to change my sign to a negative. However, sometimes you're not always going to be given a graph, and you still have to find the slope. So in your box, where it says using coordinates to find the slope, we are going to give you the slope formula. So where it says given any 2 points, so this is based on any 2 points on your line, the slope can be found using this formula. Our lowercase m is the official variable for slope. This is in your box. You're putting this in your box. The slope formula is the change in the y coordinates, and you can find those easily. That's the second number in your ordered pair, divided by the change in the x coordinates. Now, that equals to, since we're dealing with 2 points, the actual formula is y2 minus y1 divided by x2 minus x1. So this is what you put in your box on your notes. The actual formula is right here. So just in case you're wondering now, what does the little sub 1 and sub 2 mean? That's because we're taking the slope from 2 points. So the first one is the y coordinate of your first point. The 2 is the y coordinate of your second point. The same for your x coordinate and your y coordinate. Best way to figure this out, see how it works? Let's jump into some example problems. So for example 3a, I give you 2 points. They're already on your notes. Point A is at -2, 1, and point B is at 5, 7. Okay? The first thing you need to do before we even use the formula is you need to label your coordinates. For my first point, -2 is the coordinate, x coordinate. This is the first point, so x coordinate. y1, y coordinate of the first point. For point B, since that's your second point, 5 is x2, 7 is y2. And now, it's what I call a plug and chug. M is equal to y2 minus y1, so that's 7 minus 1. Divided by x2 minus x1, so that's 5 minus -2. Do you see what we did right here? This minus sign is part of the formula. So that's going to be there no matter what type of numbers you have. Since my x coordinate of this first point is already negative, you don't drop it, but you do know that whenever you have a double negative, it becomes positive. So 7 minus 1 is actually divided by 5 plus 2. Basic arithmetic. 7 minus 1 is 6. 5 plus 2 is 7. So the slope between these 2 points is 6 over 7. Right? Let's try another. Let's see. Can I move over here? For letter B, we want to find the slope between the lines, the points 4, 0, and D is located at -1, 5. So 2 more points. Same formula. I'm going to label my coordinates. There's x1, there's y1, x2, and y2, and now it's a plug and chug. Formula still here. M is equal to y2 minus y1 over x2 minus x1. 5 minus 0 is just 5. Negative 1 minus 4 is negative 5. You can simplify this to negative 1. So the slope of the line, or the slope between these 2 points, is negative 1. Now, does it make a difference which values are on top? Yes. By definition, you have to do the change in the y-coordinate divided by the x. The change in the y-coordinate, that's your rise. So if we say that the ratio is rise over run, your y-coordinates have to be the numerator. You cannot flip-flop these. It does make a difference. Now, for example 4, stop. We'll do example 4 on the next one.